Hi guys, welcome back to the channel. So today we are going to be solving third question, the bi-weekly contest third question, which is shortest subarray with or at least k, part 2. And then we are given an array of nums which is non-negative integers, and then we are given integer k, and then we need to find the length of the shortest special non-empty subarray of nums. Suppose, let's say, if the answer doesn't exist, then we need to return this particular -1 as our answer. Suppose if I take this particular element where we have 1 2 3, 1 2 3. Now we are going to return the, as we have already seen, there is the first question, which is the problem one, where we had solved by taking one for loop for the starting point and then one more for loop for ending point, and then by taking k equal to from I to j, and then doing or operation on all elements, and if number is greater than or equal to k, then we are going to consider this particular length, and then we are going to return the answer. So this is going to be our brute force approach to solve this particular example, where we'll be having big of n cube as our time complexity. So that cannot be solved with these constraints. Why? Because we have nums length equal to 2 into 10 to the power of 5, which is not possible to solve with big of n cube. So we are going to reduce this particular time complexity. So let us see how we can reduce this particular time complexity. Suppose, let's say, I have 1 2 3 and then k equal to 2. Now let us say I have 1, or I have 2 and then I have 3, and then let me take an example where I have temp equal to 2, temp equal to 0, and then I am going to calculate temp equal to temp or of nums of nums of 5. Now when I try to do this and then try to increment whenever the temp is less than k, then I'm going to insert this particular 2 into the nums, into the temp, and then the temp equal to temp equal to 3. So we are going to have left and then right pointer. Left is going to be 0 at the starting, and then right is going to be 0. And then whenever we have temp is less than or less than 2, then we are going to increment the right, and then we are going to add it into the temp. And then whenever the temp left equal to 0 and then right equal to right equal to 1, then we have already seen this particular nums. Then it is going to have the temp equal to 3, and then we are going to increment this to 2. So now we have this particular 3, and then whenever you move left to left plus plus, which is going to be left equal to 1, then we are going to remove this particular 1th bit, which is going to be like 1 1. So we are going to remove this, so this is going to be 0. Suppose, let's say, this particular element is 3. Now this is going to be temp is going to be 1 1, which is going to be 3 as our answer. And then whenever I increase left plus plus, then if I change temp to temp last bit, which is 1, which is going to be 0, then it is going to be 1 0, which is going to be 2. So but this 1 3, whenever I remove 1, then there should be 3. That means it is going to consider this particular 1th bit as well. So that's why we are going to use, instead of only one variable, we are going to use the frequency array, where it is going to store the all the bits which are present in this particular array and their its frequency. Suppose, let's say, I have 3 and then I have 2, then the frequency becomes 1 comma 1, 1 comma 1, and then 1 comma 0. Then the frequency of 1 is going to be 2, and then frequency of 0 is going to be 1. Why? Because the 0th bit is going to be only one time repeated, and then 1th bit is going to be two times repeated. So whenever I traverse from here to here, I am going to decrease the bits from the frequency, and then we are going to decrease it to 1, and then we are going to decrease it to 0. And then now when I have this particular point, we are going to have the same frequency which are there from left to right. Now if I come to the time complex, suppose let us take left and then right. So now I have left and then right. Now whenever I say the bitwise OR operation of all the elements is at least k. Now we'll start the left and then right to here. Now let's say the left, the temp variable, whatever the current number is less than or equal less than k. Then whatever we are doing the right by incrementing the right, and then we are going to add the number of the elements present in this particular nums into the sliding window, which is going to increase the length of this particular sliding window, and then it is going to increase the OR operations of the elements, which will be greater than or equal to k. Whenever this becomes greater than or equal to k, then I am going to break out of this loop. And then whenever, if it is greater than or equal to k, then we are going to consider this particular length, what that is right minus left. Why? Because the right will be incremented a step ahead the actual right where the sliding window ends. So that's why we are going to consider right minus left. And then whenever we are doing the transition, we are going to traverse this particular left to left plus plus, where we are going to start another sliding window which will be started from the next iteration. And then let's say, suppose if it has greater than or equal to k, then we will not be touching the right. Suppose let's say if it is less than k, then we will try to increment the right, and then we are going to store the length of the smallest length of the shortest special non-empty subarray. So let us go through the code. Suppose we'll take left and then right equal to 0, and then this is going to be our current frequency. And then let's say suppose the k equal to 0, that means we are going to have the OR of all operations is going to be 0. That means we are going to have at least one element. So at least one element, so that the current the OR operations will become that particular element which is going to be greater than or equal to k. Why? Because this is always the nums always start from 0 to 10 power 9, so it will always be greater than or equal to 0. That's why we are going to consider only one element, and then we are going to return this particular element, this particular frequency, and then we are going to use the current frequency. And then suppose let's say if the left is less than nums dot size, so then we are going to collect the current number which is from the current frequency, whatever the elements which are present. Suppose let's say a current frequency of 31, 32, 31. 31 is going to be the bit, whatever the bit is present in that particular element. Suppose let's say if I have if I have like 1010, then this is going to be third bit, second bit, first bit, and then zeroth bit. So this is going to store the number of the frequency of this particular bit, considering all the elements which are present in this particular subarray. So that's what it is going to store. And then let's say suppose this particular frequency where it has I is greater than 0, then we are going to consider the that particular bit is present, that is going to be OR operations on the current number with that particular ith bit as set. Suppose let's say the right is less than nums and then current number is less than the k, then we are going to add the right elements which are present in this particular nums into the sliding window, and then we are going to add the frequency into that particular element wherever the bit is present, from I equal to 0 and then I less than or equal to 31, and then we are going to increment the right. And then let's say if the current number is greater than or equal to k, then we are going to consider the answer equal to minimum of answer and then right minus left. Suppose let's say if this particular at last we are going to have the at last we are going to decrease the current frequency. Why? Because we'll be moving the left to left plus plus, so that the current frequency present at this particular left will be reduce, and then we'll be moving this particular left to left plus plus, and then at last we are going to return the answer. So for this particular element, for this particular question, the time complexity is going to be big of n. Why? Because we'll be traveling the loop only twice, like one for the left and then one for the right, and then we are going to have the space complexity which is going to be big of 1. Why? Because we are not using any extra space for this particular question.